find the extreme values of this function, relative and absolute, if that's possible. So I'd like to start by finding the domain of the function. Well, it's a polynomial. I don't see any denominators. I don't see any radical signs with variables. I don't see any logarithms. So as a polynomial, I know the domain is negative infinity to positive infinity. I also know that the end behavior of this graph is going to be up, up, because I have the highest power is even, and I do not have a negative sign in front of the leading coefficient. So if I'm going to graph this thing, I don't know exactly what it's going to look like, but I know that the end behavior as x goes to infinity negative is going to be up, and the end behavior as x goes to infinity positive is going to be up. So if I want to find relative maximums or minimums, I need to take the derivative and see if I can find where it equals 0. So first let's take the derivative. So I have y prime equals, well, 4 times 3 halves, so the 4 and the 2 are going to cancel out. That's going to be 6x cubed plus 12x minus 18x. Oh, and that's it, because the derivative of 10 is 0. So I have to find out where, or if, I can find 6x cubed plus 12x minus 18x. Where does it equal 0? Well, this is an exercise in factoring. So what I'm going to do here is I'm going to factor out a 6x, oh, that was 12x squared, I'm sorry. Let's get that back in there. I'm going to factor out a 6x, and I'm going to get x squared plus 12x. No. Come on, Glenn, you can do this. Plus 2x minus 3 is equal to 0. And that is a whole lot easier to factor than this bigger number. So I'm trying to find out where it equals 0. I can tell right away that when x equals 0, that's going to make this whole thing equal to 0. And if I factor this, I find that I have x, and I have plus 3 minus 1. So where x is equal to negative 3 and x is equal to positive 1, any of those values of x are going to make the derivative equal to 0. So my critical points are all stationary, and they are x equals negative 3, 0, and 1. I don't have any values of x that would make this undefined. The derivative exists over the entire domain. So the domain of the derivative is also negative infinity to positive infinity. Well, let's find out what these actual points are going to be. So here is our function. I just copied it. And I'm going to just substitute our x values. So I want to find what is f of negative 3. Well, I'm going to have 3 halves times negative 3 to the 4th power plus 4 times negative 3 cubed minus 9 times negative 3 squared plus 10. Well, this one's going to take a little bit of arithmetic, I think. So that is equal to, if you worked it out, it's going to be equal to, this is going to be 243 halves. It's going to be positive because the negative 3 to the 4th power is going to be a positive number. And this is going to be minus 216 halves. And that's going to be negative because the negative 3 to the 3rd power is going to be negative times the positive 4. And and this is going to be minus 162 halves, again positive, because the negative 3 squared is going to be positive, but I have a negative sign here, plus, well, 10 is easy, that's going to be 20 halves. And when I worked out all the arithmetic, and you could do this too, it's just a little bit tedious, it comes out to be negative 116 halves, which is negative 57 and 1/2. So one of my points, I'll write it in black over here, is the point negative 3, comma, negative 57 and 1/2. All right, let's try. I need to find it also for 0 and for 1. Well, those should be quite a bit easier. So I want f of 0. Well, this is going to be 0. This is going to be 0. This is going to be 0 plus 10. So that point is going to be 0, comma, 10. And then my last point is f of positive 1. Make sure. Yep, f of positive 1. So this is going to be 3 halves times 1 plus 4 times 1 minus 9 times 1 plus 10. So that is the point 1, comma, 6 and 1/2. Well, let's look at what this graph is going to look like. So I'm going to make a model of the graph. And what I knew from the beginning here was that I was going to have up, up, and behavior. And I know I have 3 points where my derivative is equal to 0. I have one at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I have one at negative 3, well, way down here, so let's call this negative 3, 57 and 1/2. It's obviously much lower than that, but I think it'll serve our purpose. I have one at 0, 10, 0, comma, 10. And I have another at 1, 6 and 1/2. 1, 6 and 1/2. Those are the only possible places that I can have a relative maximum or a relative minimum. And, you know, a relative maximum is a turning point like that, and a relative minimum is a turning point like that. And I know that I'm going to have up, up, end behavior. So I know that my graph is starting from up here someplace, and it has to come down, and the first place it can possibly turn is right there. So it's going to turn around, that's going to be a relative minimum, and it's going to go up, and the only place it can possibly turn again is going to be right there. And then it's going to go down, and the only place it can possibly turn again is right there, and then it has to turn around and go up forever. Can't do any more turning around, because those are the only points that I have possible relative minimums or maximums. It's going to go up forever like that. So I can see that my negative 3, 57 and 1/2 is a relative minimum. I can see that my 0, 10 is a relative maximum. And I can see that my 1, 6 and 1/2 is a relative minimum.